In this video, we are going to learn how to use sum and difference formulas to find exact values. Now, I've written the 6 sum and difference formulas at the top for easy reference as I go through these problems. So let's look at the first one. I find the exact value of these expressions. Now, 75 degrees is not an angle on the unit circle, so it's not one of those regular 30, 45, or 60 degree trig values. We actually have to use the sum and difference formulas to find its value. So cosine of 75 degrees can also be written as cosine of two angles added together. Why not 30 plus 45? That does make 75. So what I'll do is I'll write this as 45 degrees plus 30 degrees. And now I can use that sum formula for cosine to evaluate this. So now I can write cosine of 45 degrees times cosine of 30 degrees minus sine of 45 degrees sine of 30 degrees. And now I can evaluate each of these angles using those unit circle values. So that gives me square root of 2 over 2 times cosine of 30 degrees, which is more out, so square root of 3 over 2 minus square root of 2 over 2 times sine of 30, which is only a half. So that gives me square root of 6 over 4 minus square root of 2 over 4, which I can put it all over the same fraction, giving me square root of 6 minus the square root of 2 all over 4. Now I can do something similar with tangent of pi over 12. Again, pi over 12 is not a value on the unit circle, so I have to think of another way to make pi over 12. Well, one way to do this could be the tangent of, let's say, 3 pi over 12, which is also known as pi over 4, minus 2 pi over 12, which is pi over 6. So now I have the tangent of pi over 4 minus pi over 6. So now I can use the difference formula for tangent to evaluate this. So it becomes tangent of pi over 4 minus tangent of pi over 6 all over 1 plus tangent of pi over 4 times tangent of pi over 6. Now if I go to evaluate these tangent functions, I get tangent of pi over 4, which is 1, minus tangent of pi over 6, which is the square root of 3 over 3, all over 1 plus those same values multiplied together. So 1 times square root of 3 over 3. Now, I do have a fraction within a fraction, so I'm going to multiply the numerator and the denominator by 3 to get rid of those fractions. So I have 3 times 1, which is 3, minus the square root of 3, because the 3's will cancel there, and 3 times 1, which is 3, and 1 times 3 square root of 3 over 3, the 1 goes away, and I'm just left with the square root of 3. So that would be the value of tangent of pi over 12. Now lastly, may have a whole bunch of angles like 80 and 20, which we don't know, but this format that they're being multiplied and then subtracted in between reminds me of sine of alpha minus beta, ideally being sine of alpha being 80, cosine of beta being 20. Then normally you would have minus cosine of alpha, which is still 80, and sine of beta, which is still 20. So if I just imagine that alpha is equal to 80 degrees and beta is equal to 20 degrees, I can rewrite this expression as sine of alpha, which is 80 degrees, minus beta, which is 20 degrees. And then I can evaluate this expression instead. So sometimes you can use it to reduce your expression. This is just sine of 60 degrees, which is the square root of 3 over 2. Now let's look at it whenever we're given some arbitrary values for sine of alpha and sine of beta and see how we can still find all of these values. So here we know that sine of alpha is 4 over 5. And it's between pi over 2 and pi. So if I use this grid over here, pi over 2 is the upper angle, pi is the left angle. So I know I'm between these two angles for sine. So sine is usually opposite over hypotenuse. So if I imagine an angle going out, the opposite side will be 4. So it goes up to 4. And has a hypotenuse of 5. And now I want to find this remaining side so I can evaluate cosine of alpha. Now, since I'm in the second quadrant, my x value should be negative. So I can use the Pythagorean theorem to give me 4 squared plus b squared is equal to 5 squared. So 16 plus b squared is equal to 25. B squared is equal to 9. So b is equal to negative 3, because I need that to be a negative 3 on that side. So cosine of alpha is equal to negative 3/5. Now let's see if we can find cosine of beta. Now I know sine of beta is negative 2 over the square root of 5, or when rationalized, negative 2 square root of 5 over 5. I'm going to use this first one for my triangle since it says one number over the other. And that is between pi and 3 pi over 2, which puts it in the third quadrant. So what that means is my vertical side will go down 2, and my hypotenuse will be the square root of 5. And since I'm in the third quadrant, my x value should also be negative. But again, I can use that Pythagorean theorem. So negative 2 squared plus b squared is equal to the square root of 5 squared. So 4 plus b squared equals 5. B squared equals 1. So b is equal to negative 1, because I know I need my x to be negative, making cosine of beta equal to adjacent over hypotenuse, negative 1 over the square root of 5, which can rationalize to negative square root of 5 over 5. But now that you've gone through all of that, we can now figure out what cosine of alpha plus beta and sine of alpha plus beta is. So I can use these formulas because I know that cosine of alpha plus beta would be cosine of alpha times cosine of beta minus sine of alpha sine of beta. And luckily I have all of these values to plug in, because now cosine of alpha is equal to negative 3/5. Cosine of beta is negative square roots of 5 over 5. Minus sine of alpha is 4/5. And sine of beta is negative 2 square roots of 5 over 5. Now, when I multiply these together, I get 3 square roots of 5 over 25. Here I have minus a negative here, so it becomes plus 8 square roots of 5 over 25. And all together it gives me 11 square roots of 5 over 25. And I can do the same thing for sine of alpha plus beta, because that is equal to sine of alpha cosine of beta and then plus cosine of alpha sine of beta. And going through and plugging them in, sine of alpha is 4/5 times cosine of beta, which was negative square root of 5 over 5, plus cosine of alpha, which was negative 3/5 times sine of beta, which was negative 2 square roots of 5 over 5. So then multiplying together, I get negative 4 square roots of 5 over 25. And then this will be plus, because negative makes it a positive. 6 square roots of 5 over 25, which altogether gives me 2 square roots of 5 over 25. And that is how you use the sum and difference formulas to find exact values.